So we are going for the eccentric load. In previous we have seen the eccentric load. Now this is eccentric load on a bracket with circular base. Okay, now for the circular base, eccentric load on a bracket with a circular base. The base of a bracket is made circular as in case of flange bearing of a heavy machine tools and pillar crane, etc. For this we use it. So consider a round flange bearing of a machine tool having 4 bolts. So this is a view, and here radius r, it is outer, here radius r for pitch circle of a bolted joint. 1 2 3 4 are the, this is the length from the base, L1 L2 L3 and L4. okay, for the bolted connection from the bottom part. So this distance are known. Here the load is acting at this point, and from this part, from bolted region to this, having a distance L. Okay, now let's see. So capital R is the radius of the column flange, small r is the radius of the bolt pitch circle, and W is the load per bolt. Okay, capital L is the distance of the load from the tilting edge. Now L1 L2 L3 are the distance of from centers. So W into L will be what? The external movement. So small w into L1 square plus L2 square plus L3 square plus L4 square. So small w is equal to what? W into L divided by this times. So this is how it will generated. Now from the geometry of figure which we have seen in the last slide, L1 is equal to what? R1 capital R minus small r cos of alpha. L2 is capital R plus small r sin of alpha. Same thing for L3 and for L4, L3 and L4. Okay, so we get it. L1 and L4 are same, L3 and L2 are same, only the sin and cos is changes here. So L1 L3 is having a cos and L2 L4 are having a sin. So just remember in this way. Now substituting these values in equations, that is the first equation which we have seen, what we get, small w is equal to W into L divided by 4 times R square plus 2 times small r square. This is how we get a load on per bolt. So load in the bolt situated at 1 is equal to what? Small w into L1. So small w into capital L into L1, based on this we get a formula. So at point 1 this will be the formula for calculating the load. Same thing, this load will be maximum when cos of alpha is minimum, that is when cos of alpha is equal to -1 or alpha is equal to 180 degree. So at this point this equation will become, in general, if there are n numbers of bolt, then load in a bolt, that is 2WL into capital R minus small r cos of alpha divided by small n 2r square plus small r square, we get it. So the maximum load in a bolt is what? This thing. This is the formula for it. Wt is equal to 2 times WL capital R plus small r divided by n into 2 times r square plus small r square. So this above relation is used when the direction of the load changes with relation to the bolt, as in case of a pillar crane. But if the direction of load is fixed, then the maximum load on the bolt may reduce by locating the bolt, and it is given by this term, that is this. So this is how we can calculate it, Wt. I think you understand this part. Okay, thank you. So knowing this,